So, hello guys. Welcome to our sixth lecture. I don't know, I can't count. Today we're going to be talking about communication. First things first, how do I go to next? Okay. So yesterday we had a Sprint 1 tournament. Congratulations again to Gone Sharking who won. We did notice a few things that we want to adjust just to have a more healthy meta. So here's a sneak peek of the most important balance changes we're gonna do. First, we're nerfing explosive traps by a pretty decent amount. So the damage and radius are both going to be nerfed by a pretty substantial amount. So they should still be pretty strong and viable, but it's going to be in a much more concentrated area, and it's going to be a lot more of a decision of what locations you're going to place them on. The next thing is we're buffing attack specialization at level 4+. So at level 4+, this is when you can't uh specialize in multiple skills at one point. And so we noticed that most teams just only do healing robots. So we're trying to incentivize teams to have a healthy mix of attacking, healing, and voting robots. We also changed global upgrades. I don't know if you guys noticed, but in the Sprint 1 tournament, everyone got the exact same global upgrades at the exact same time. That's not very enjoyable, and that just makes it seem like there's no point. This is a much more in-depth change. Basically we removed one of them in exchange for just a flat attack damage increase, and then we changed some numbers around and so on. That one, it's probably best to just look at the specs. Next, turning water into lands, we made that more expensive and gave it larger cooldown. That way you can't just fill every piece of water you see. It's actually a decision. And then last thing is just units can no longer self-heal. So it's no longer as easy to just get healing experience, but healing yourself. You need to be with someone else. Okay. So what we're actually going to talk about today is the communication model. I don't know if you guys noticed, but basically every robot is sandboxed. So they can't access each other's variables, even if they're static. They get their own copies. So, but you still want them to be able to communicate with each other somehow and be able to come up with a larger team play. And so the way we do this is we provide a shared array, which is something that every robot on a team can access and write to. So the specific bytecodes, I believe if you haven't changed them, is writing takes 75 and reading takes 2 bytecodes. So that means that it's pretty feasible to just loop through your entire array and just read all of the information in a given turn. And it's not going to be too computationally expensive, but writing to it and updating is going to be a bit more computationally expensive. One thing to note is that you can always read and write. In previous years, we had a lot more restrictions on when you can read and use the shared array. Here, you can basically always communicate, even if your robot is jailed, which is kind of weird, but it's something to keep in mind that even if a robot is jailed, you can use some sort of communication for it to figure out what spawn zone do I need to defend, where should I spawn, decisions like that you can still do. One thing to note is that an array is an array of integers, so specifically less than 2 to the 16. So you can't just put anything in your array, but you have to put numbers in your array. Okay. So the first main thing you probably want to put is a location. And it's pretty obvious that you're gonna want to put locations. There's enemy locations, flag locations, spawn zone locations, dam locations, all of that kind of things. Once you find them, you want to have some way to communicate that to the rest of your team. The issue is you can't just stick a map location object in an array of integers. So does anyone have any ideas of how we can put that in an array? And I'm looking at you guys. See if you guys have any answer. I will stay here all day. Okay, you guys called my bluff. Okay. So the most obvious thing you can consider is every location is just a tuple of an x and a y coordinate. So you can just say let me save the x coordinate and then a y coordinate in two adjacent indices. And then every time I read a location, I just read like a pair of indices and I get the x coordinate and the y coordinate. The issue is like, that's like kind of inefficient. So what I can actually show is here. You can imagine like taking a grid and like numbering it. So if you look at this like middle one right here, which you guys see my mouse? Actually, yeah, you guys see my mouse. So like in this grid, you take like the bottom left corner and you number at 0, and then you go all the way to the top right. So like 0, 1, 2, 3, 4, 5, 6, 7, 8. And then that way, you can code like a pair, like a map location as a single number. And that's much more convenient because then you only need to take up one spot in your shared array for a given location. Which, given how like limited the size of it is, it's only 64 long. You don't want to be able to be limited by like only being able to save 32 locations. One small optimization you can do is just increase everything by 1. So then that way, like your bottom left corner is 1 instead of 0. The reason that's nice is because like obviously when the shared array is initialized, everything's 0. So you can see that if it's still 0, then it hasn't been updated at all. That just differentiates like the bottom left corner from like the initial value, just by shifting everything by 1. So like the actual math behind it, you can see like location to like this function on the left side. Like you add 1, and then m.x, so the x coordinate, plus m.y times the width. So this kind of looks like a bit magical, but like you can see like here, like at 0, 0, it's just 1. And then when you go to the right, when you increase the x coordinate by 1, then you just want to increase the actual number that's encoded by 1. So you just add m.x. And then when you go up 1, so when you go like 1 to 4 to 7, the number you're going up by is 3, which also happens to be the width of the map. So then that's how you can go from like a map location to a number pretty easily. And then given this, it's pretty easy to just like turn like whatever number you came up with back to a location by just like subtracting 1 to account for like the 1 you added at the beginning, and then just doing like modulo the width to recover the x and the y coordinate separately. Okay. So then the main thing is, what do we actually want to put on our stored array? So I kind of went over this like kind of quickly. The main things we're going to want to do is probably like flag locations and enemies. Those seem like the two most immediately obvious things that are like important and somewhat easy to keep track of. It's completely up to you. Like we are going to be like starting to implement this today, but there's deliberately going to be like extra like indices or like bits that we haven't used. So we're deliberately going to be like leaving more space in shared array for you guys to take advantage of and be able to like add these new things that you want to keep track of. And then specifically about flags and enemies, the main things we want to keep track of is just like the location of the flag and or the enemy, whether or not the flag is being carried. That way you can differentiate between like a flag that's on the ground and a flag that's being currently held by an enemy robot. The number of enemies on like the location. This one, it's not immediately obvious why we need like the number of enemies, but the reason we do this is because we don't have enough like spaces in our shared array to have like one index for every location. So instead we're going to do like approximate locations, and we're going to do like the number of enemies in the approximate location. It's also not terribly useful to have like exact locations of enemies because the exact locations of enemies are changing every turn. And so you're going to be using like a lot of computational power just to show that one enemy moves 1 round in 1 tile. And also we do just want to keep track of like how updated information is. So like you consider like if you see an enemy robot like on a tile on round 205, on rounds like 1300, you shouldn't read that same thing and assume there's still an enemy robot there. Like obviously in 1,000 rounds, that information is no longer up to date. Okay. So we will actually start implementing it. So I just created a communication class, which is where we're going to put like a majority of our code. Let me actually zoom in. Okay. Is this viewable? Thumbs up. Okay, I see thumbs up. Okay. So I just created like these two methods that I talked about in the slides, like the converting an integer to a location and a location to an integer using our encoding. Does anyone have questions about these? Or otherwise, I'm just gonna move on quickly. Okay, I see no raised hands. Okay, so the first thing we're gonna do is probably just like encode the number of enemies that we can see around us. So I'm gonna go into our main phase. So we can see like right here in this code for attacking enemies, we're already sensing the enemies. So what we should do is after we sense enemies to see who we can attack, we should also just like share that info to the rest of the team. So in our communication class, I'm just going to create a method called like update enemy info, which isn't going to take anything. So we're going to pass it like a robot controller RC, which we do like for everything, like the location we're currently at. And then I'm going to do like the number of enemies we see. I'm not gonna actually implement this right now. Max is gonna implement this like later in the lecture. Mainly because there's like a few intricacies that we can do to like optimize it and make things a bit easier. So that we'll get into later. So to be implemented later. But for now, I'm just gonna assume the method exists. So then when we're looping through the nearby enemies, what we can also do is communication. Well, okay. Instead of updating each enemy individually, we're just going to update them like together. So communication that update. Why is this okay? Okay, update enemy info. We pass in the robot controller. We pass in our current location. And then the number of enemies is just the length of the nearby enemies array. The length. Okay. So this way, once we implement this like magic method, I just assumed works, should actually like write in the shared array that at this location we have this number of enemies. Okay. So other than that, the other thing that I wanted to mainly do was flags. So right now we only sense enemy flags. What I'm gonna do is I'm gonna sense all flags. So we create an array, all flags, and we just sense nearby flags. One thing you can always do is just pass in -1, just get like the largest possible radius. So then for like a flag in this all flags array, we're gonna also want to update this info. So I'm gonna do the exact same thing, the same cop out, and I'm just gonna create like an update flag info class that will also be implemented later. So we're also gonna want to do a location. One thing we also want to do is whether or not the flag is being carried. And then for convenience, we're gonna pass in an index. Like what index in the shared array we want to write to. So what I'm actually gonna do right now is I'm just gonna like quickly sketch out like what my shared array is gonna look like. So my shared array has like 64 indices. I don't want to just like mix my flag info and like my enemy info like all over in a shared array. I want to make sure just like a clear distinction. That way, if I read an index, I know immediately whether it's talking about like a flag or an enemy and what info comes across that. If you mix it and just like add it all the way to the end, you're probably gonna need like either like adding bits to like encode whether or not it's a flag or an enemy or like some other form, some other like saving of what it is. So what I'm gonna say is the first 6 indices is going to be from flag infos. So I'm just going to pass in the specific index I want to do it in. And then because I'm going to be like a good programmer, I'm not going to do like random numbers. So I can do like create a constant for like last flag index, which is going to be 5. And in that way, I know, okay, from 0 to 5 inclusive, there's all my flag indices. I don't think we're actually going to use this constant anywhere, but for future use, once you like start expanding it, it's useful to just like keep track of like what you want to be saved in your shared array and make sure you're being consistent with that, just so you don't run into like a lot of mishaps. Because I've definitely tried using the shared array and not being like this clear, and then it becomes a mess. Okay, so once we have this method, we're gonna call our magic black box method, update flag info with a robot controller that we pass in. Location. This is luckily easy with just like flag that get location. I don't know why it's like that. Whether or not a flag is carried is also easy for like flag that is picked up. And in the index is slightly more difficult. What would be ideal is if every flag got saved to an index like consistently on like one space. And the only way we can like differentiate flags is like by their ID. So int flag ID is flag that get ID. The issue is, for some reason, we decided that flag IDs are basically like the initial location they are. Which if you happen to like do the math a bit, can take up to 12 bits to encode. We only have 16 bits. And so it's like, first of all, we can't use the flag ID as an index. And it's very cumbersome to actually store it in an array because it takes up a lot of space for something that's just like one of 6 values. So I'm going to create like a helper method. So like index is like, I'll call it like flag ID to index. And then flag ID. So let's create this method and I'll create it at the bottom. So public static, we're going to return an integer. I'm going to be consistent actually, and I will not use underscores. Flag ID to index. So we create this flag ID to index, and we pass in. We should also probably pass in robot controller because we'll probably also need that. Robot controller C, and then int flag ID. So we could just create like a hash table. This only has like 6 possible values, so I think a hash table is like kind of excessive. So we can just like save a static variable instead. So we can say like static int array of like flag IDs. Okay. So basically, initially this is going to be like 0, 0. Well, actually initialize it. So flag IDs is new int 6. Okay. So now that that's initialized, we're just gonna assume that it has flag IDs in it right now, and if it doesn't, we're gonna add our ID to a specific index to assign it to an index. So for int I equals 0, I is less than, I don't even know what I called it, flag IDs. Okay, that's like kind of a bad name, that's fine. So if it's 0, then that means we haven't updated it yet. So then we can do like flag IDs sub I is our flag ID. And then we just return our index we just assigned it to. Otherwise, okay. Otherwise, if it's the value you want, okay, if I can type flag ID sub I is equal to our flag ID. So basically that means we've already gone through and we've assigned this flag ID to an index. then we found the correct index and we can just return I. Otherwise, oh, this is not linked. That's why it's complaining. And otherwise, if it's not 0 and it's not a flag ID, that means that we have a flag, we've assigned it to an ID and it's different than this one. So we can just like continue, which isn't like strictly necessary, but I will do it for like parent, really. So then this should always be fine because there's only like 6 flags, so 6 possible flag IDs. Or just in case something terrible happens, I'll just return 0. Okay. So now that this happens, we can figure out what like index in the chain array you should assign it to. Okay. So we have flags that's being updated, enemies that's being updated. We should show like an example of like what is actually using this look like. So if we scroll down a bit down here, we have this section where basically we search for nearby enemy flags. And then if we have no enemy flags, then we sense the broadcast flag locations and we just treat those as flag locations. What we can do instead is if we see no enemy flags around us, we should also first check if other teammates have found an enemy flag. Because if other teammates have found an enemy flag, then we know that's the true location and we should be using that instead of the broadcast flag locations. So here, let's just say for int I equals, and this is where it matters, like these variables I set up, like the last flag index. So because I created this like helper thing, I know like where it begins and where it ends. I know it begins at 0 and it ends at 5 equals plus. So then if it's, we can say like, it's gonna be like kind of hard. You'll see like based on how we're encoding it to actually get information out of it. So I will create more black box methods like public static void. Well, public static map location, get location from an index. And then I'll say to be implemented also. So we can just do that. I guess we should probably also do like the team. Just to be safe. Flag.get team. We actually call it. And here in update flag info, I should do like team. Okay. And then we should also get something, just get the team out of flag index in action array. Public static team, get team, robot controller, RC index. And I will also not implement this. That's kind of a common trend. But now that we have these magic methods that will be implemented later, we can just say if communication dot get team at this index. So we pass in our robot controller and the index. If it's equal to rc.get team dot opponent, if it's equal to our opponent, which means it's an enemy flag, then flag logs that add communication that get location. And same thing, we pass in robot controller and we pass in the index. So just like that, if we see no enemy flags, we start going through like the first 6 like indices in our chain array, and we check if any of them have like a flag of the enemy team, and if they are, then we add that location to our own information. And this way, we can say like if the size is still 0, then we can start looking at the broadcast locations. Let me just invent this. Okay. There is one more thing we need to add that I have not discussed yet. Basically, all of our information, so far we do not have any way to check if it's up to date at all. So there's a few ways we can go about doing this. Do any of you guys have any ideas of how you'd make sure like your information in the student array is up to date? And there's like a lot of different things you can do. Yeah.
How about the counter for the rounds that is written?
Yeah. So that's something like the most immediate thing you can think of. It's just like when you write to a student array, like have some of the information you write be like what round it's written in. If you do like the math on it, I believe that takes like because a round can go up to like 2000, that can take up to like 11 bits, which is actually like a lot considering in each index you can only have like 16 bits of information. So definitely something you can do if like you limit how much information you put in your string array. We're gonna take a slightly different approach. One that you can consider is like in the very extreme, I want my information to be like only up to date like for this round. So the very extreme thing you can do is just like every round completely wipe your string array. And in that way, when you read from it, you know that it has to have been updated that round and it has to have been like up to date. That's gonna be like slightly annoying. So what I'm gonna do is I'm gonna okay, I'm gonna take like the first, I'm gonna assign each robot like an ID. And then if a robot has like ID 1, then I'll say this robot is responsible for clearing the string array at like the beginning of its turn. So then I'll say if RC like can write string array 0, then RC that write string array. And here I'm gonna write to like the last possible thing. So I believe it's gonna be like 63, and I'm gonna write it, I'm gonna just increment it by 1. RC, well, I'll say like int personal ID is RC that read string array at the location. And then I'm just gonna increment it by 1. Personal ID plus 1. So this way it starts at 0, then every robot, it's gonna read the current value, take that as their personal ID, and then increment it by 1 for the next robot. So that way every robot gets like their own personal ID. And then I will just write this here. Last index like used for giving robots the personal ID. Okay. Ideally, this should only happen once, so I will actually move this code over to robot player so that it doesn't happen in the setup phase, but like at the beginning. So I will move this here, and then I'm gonna make it a static integer so we can access it from other classes. And then here I can just do personal ID. And that way, now that I've moved this here and say if robot player that personal ID is equal to 0, that means this is like our designated robot that we decided is gonna delete our string array basically. So for instance, I equals 0, I is less than like 64 x plus. We can say like RC that write string array the current index, and you can just write 0. That way, every round it's completely wiped. One thing you can consider is this like incredibly excessive? You do not want to just like completely wipe away every piece of information you have every round. So instead, what I'm gonna do is I'm not gonna completely wipe it, but I'm just gonna set it equal. I'm just gonna like flip a bit to denote that it's not updated this round. Set like unupdated. And then I'll pass in robot controller in our index. And then, did I spell it right? Yeah, unupdated. Okay. And then I'll just create like a helper method here. Public static void set unupdated. That we pass in as a robot controller in an index. And then I'll do like a corresponding like getter method public static boolean get if updated. Robot controller, RC and index. And then also, I'm just gonna like do values so it compiles. Even though this is not how it should be. Okay. Return team dot neutral. And then return team application 0. And return. And then return. Okay, now it's like no longer yelling at me. Okay, so then now that we've set each index of like a value denoting whether or not it has been updated this round, we can do things like when we're doing our flag info, which I can see like where we're doing it here. At first, we were just checking if the team is equal to the opponent, but now we can also do like we can check if it's been updated this round. Get if updated, like the robot controller and index. So in that way, we don't add any like deprecated information to like our flag locations array. And instead, we only add it if it has been updated this round. Okay. I believe that's the main things I want to do. And then Max, are you ready? Yeah, okay. Max will follow through and actually implement these flag box methods and talk about things you want to keep track of with respect to that. Yeah. It's like a flip on.
Hi, okay, good. This work. So, I'm going to implement these methods. So let's start with, let's see, we will start with get location here. So comment this out for now. So we want to get location from the shared array. So first we have to read the shared array at the index we want. So we make a new int variable, int value equals, and we read shared array at index. And it looks like we probably want to throw game action exception here. And then, well, where's the location stored? It's in, well, you could do it multiple ways, but the way I'm going to do it now is the largest place value 12 bits of the 16 bits. So the way to do that is int location number equals, so you take value and then you want to shift over the biggest place value 12 bits so that they are the only bits. So use the right shift operator, and 4 is the number of bits we don't want, and the last few bits get dropped. There are other ways to do this too, like using integer division. But so this is a nice and clean way to do it. So now we have the location number, and we can map location. So we want to use this method down here. We want int to location. And then we plug in this number. Oops, we want robot controller too. Okay, so now we read the location and we have to return it. And I'm pretty sure that this is how we store it for both the enemies and the flags. So this should work for both. Let's see what other methods there are. So there's also let's do get if updated. So for this method, well, we need to know where the updated bit is stored. And let's make it stored at in the very last bit. So the even or odd bit. So we want to first read. And then we just need to do Boolean updated. So basically want this to be true if it's odd. So we can say value mod 2 equals 1. And it's false if it's even. So this will return the last bit, which is what we want. And now, what about set unupdated? Well, this is going to be pretty similar. It's just that this time we set the bit instead. So we're going to make this zero game action exception so the compiler doesn't say that's bad. And then we want, first we need to calculate this thing. So the number, or basically what we want to do to the number is make it odd. So if it's even, add 1. If it's odd, leave it the same. Or sorry, even, because it's unupdated. So if it's odd, subtract 1. And if it's even, then keep it the same. So what we can do is first read the value. Then we want, so the new value, we're going to do value. And then the operator here is bitwise and this basically does like and between 2 bits. So like if they're both 1, it returns 1. And if one of them 0, it returns 0. And yeah, so then if we want to make sorry, so it's the last bit. So we can do value and bitwise negation of 1. And this is just like the number of 1s in every bit except the last bit. So when we do and between value and this, then it will set the last bit to 0 no matter what, and it won't change the others. And then we just want to do if n right shared array index and new value, then right. So that's set unupdated. Now let's do get team. Well, we have to decide how teams are stored first. So the most basic way to do that would be like 0 is neutral, 1 is team A, 2 is team B. But like we only have 1 bit for this. So let's just say 0 is team A and 1 is team B. So well, at the very end of this function, we will want team equals, then we have this number that we read, int number, set that later. So if team number equals 0, then team.a, else team.b. So now we need to read from the array. So do the same thing we usually do, read shared array of index, right? And oh yeah, we need to copy this thing. It might be okay. Sorry, I use Windows. Wait, how do you undo? Wait, that's not working. Oh, there we go. Okay. Oh, right. Wait, I did control. Man, see, okay. Okay, there we go. So we have this value. And this should be the same as team num. So let's just get rid of this. And I think this is all. This is a short one, then return. Let's just check. So if the array contains, oh, sorry. We need to do so we need to access the correct bit. So let's say that we want to store the team in the second bit from the right. So like the place value of 2. So in that case, we need to extract this bit. So first we're going to get rid of all the bits to the left of it by taking this number mod 4. So this will return like only the last 2 bits basically, and we don't want the last bit. So then we're going to integer divide, or you can also shift right by 1. So integer divide by 2 or shift right by 1 should do the same thing in this case. So this will return the second bit from the right of value. And if that stores the team, then we're good. Okay, so updating enemy info is a little bit harder because we will need to run through all the locations in each of the like the clusters of robots which have been sensed and stored. And we need to check if there are any which are like close enough to the current location so that we can just like reuse them to approximate the number of robots in that area. So let's make a new variable and do static int. So this is the number of clusters of enemies that we've sensed so far. So we need to loop through them all. And also let's just we can put an extra variable here just in case we change things up, even though usually this is going to be start enemy index. So usually this would just be one more than this, but just in case we switch things up later, let's just keep it like this. So we're going to do we need to move through all the indices which contain enemies. So let's also last enemy index. This is going to be 62 because we're using 63 for something else. Less than or equal to here. Sorry, what? Wait, sorry, I can't hear you very well. Oh, yeah, yeah, you're right. Okay. Yeah. So those were supposed to say index, yes. So now we need to read at that index. So or maybe we can actually just call these helper methods here. So we want to read the location. So let's just do map location. Yeah, we need a new variable. Let's call this a location equals what is it called? Get location. Okay, so now we have this location and we need to check if it is close enough so that we can reuse it. So, because we're only going to have, we're not gonna have enough space to store like one of these at every location. So, we just want to make a new variable for how close we want to allow. So, let's say, enemy cluster radius squared equals something, whatever we want it to be. If enemy location dot radius squared. I don't know why it's not coming up. This is correct. Okay. Oh, there we go. Thanks. So that's good. If this is less than or equal to a variable, then we want to write over the old values. So there are a few things we need to do. So if we want to like save bytecode, then we should probably write these all in one call to write shared array. You could also do multiple if you're not worried about bytecode, but let's do this. So we're going to have this value thing, and it's going to be composed of multiple parts. We're going to first have the location, but we already have that. So this is just location to int enemy location robot controller, yes. Enemy location. And then this should be in the biggest 12 bits. So we need to multiply by 2 to the 4th, which is 16. And then in the smaller bits, what we're going to want is, let's see, so for enemies, we want the number of enemies. And is there something else? So we have the location, the number of enemies, and the updated thing. And I think that's all. So let's just do this. The number of enemies is going to be stored in bits, let's say 3 and 4 from the right. So place values 4 and 8, I think. So we can only store like 4 values because it's only 2 bits. What we're going to do is take the number of enemies, and if it's 0, we put 0. If it's 1, we put 1. If it's between 2 and 4, we put 2 to represent a small number of enemies. And if it's bigger than 4, we put 3 to represent a big number of enemies. And if you want to extend this and make it more precise, you could use an extra bit, because I think there's 1 extra bit in here. So let's just do this. So we have int enemy group size, and then we can just do something basic like the number of enemies is at most 1, and we just question mark. We just do the same thing, 0 or 1. And if it is at most 4, but not at most 1, then we want to put 2 and else 3. So then we put enemy group size here, multiply by 4, put in the correct bits. And then the final thing we want is if it's updated this turn, and we're updating it. So yeah, it's updated, of course. So we add 1 because that is in the last bit, I think. Let's check. Yes, that's in the last bit. And then we need to write this value. So if write shared array of our index, which is index and value, we write the value. Now, we don't want to do this for every location which is close enough. So we, of course, need to return after this because we've accomplished what the method said. You could modify this so that it updates all locations which are close enough, but I'm not sure if that would work better. So let's just do this. So now if it does not find the location one that we've already stored. And like it's not close enough to any using this radius squared here, then we're going to make a new entry in our shared array. So basically we do a new index. So we want start enemy index plus number of clusters. Check that there's no off by one error, right? If number of clusters is 0, then this will give the first index, which is good. And then we need to increment. And then we need to calculate this value. So this is going to be basically the same. We want the enemy group size. We could put this in method to clean up the code. Then we want the location and updated, which will be true. So then we can make this. This is literally the same location to end of RC and location this time. 16 plus group size times 4 plus 1. And then RC, I'm just going to copy this. Oh, delete apparently works like backspace on this computer. Okay, interesting. Okay, there we go. So let's make sure we're doing everything. So it loops through the indices, and we actually might want to stop at the last index we know of. So let's just do start enemy index plus the number of clusters which have been stored. And this should probably be less than. This way it won't waste time or bytecode. And yeah, so this updates the enemy info. So let's look at the other methods. One left. So for updating flag info, this is basically the same, except it's a little bit easier because there are only like 6 locations. So, and we are also given the index here. So all we'll need to do is we need to put this together into one int. So let's see, how's this stored? Well, we need the location as a number. So location to int RC location times 16 plus, so we can decide how we want to store this, but let's say that we want is carried and has been updated this turn to be in a group of 2 bits. And then the team is stored in the remaining 2 bits. So let's put the team here. So we want to convert this to an int. So we can make a new method. Oops, this should return int. And basically we just want to return it was 0 if it's a, team equals dot a, and we can use equals here because it's an enum. That should be fine. 0. Actually, this should work fine. So So we put the team in place value 4, let's say team to int of team times 4. And then we have 2 bits left. So we put in is carried. We want to convert that to an int. So let's do is carry question mark 0. I don't know if Java can just like convert like Python does. Times 2 plus 1 for it is updated. Then write the value. Hopefully still there. Yeah. Game action. Goes. Okay. I think that's it. Great.
There's like a few more things I just want to like talk about real quick. This is like the main things. First of all, does anyone have any questions or everything? Like, I know we went through a lot just now. So, if there's any questions, like, please ask now. Okay, I don't see anything. Feel free to just like yell out if you do. So for now, we're just gonna talk briefly about next steps. We did like just go through a lot, and we don't want to make lecture player like super duper good. So I'm not actually gonna implement anything I'm gonna talk about right now, but I'm just gonna briefly talk about like next steps. So one thing is we're like updating the enemy info. We're not actually using the enemy info at all right now that we've saved. We're definitely using the flag info because we use that if we don't have any flags that we can sense. The enemy info, we update it and we don't use it. And this one is actually a choice of what you can do. You can consider like, if you see a large group of enemies, you can consider, do you want to avoid that group of enemies? Do you want to fight that group of enemies? Like, do you want to assume that group of enemies is like attacking your flag? Maybe you like go defend if it's you like defend the closest flag to that large group of enemies. Or maybe like if your robot's holding a flag, you path away from that large group of enemies. So we have like the framework for you to be able to like check, oh, like how many enemies are in this like approximate region. And that's gonna let you do decisions like that. But for now, that's kind of convoluted to go into. So we're not gonna do that. Other things is we probably don't care too much if it's been updated in that exact round. So probably messing around with this, maybe like updating it, setting things to unupdated like every 5 rounds, something like that. That would allow you to retain information as recent, like a bit more often. It depends, like it probably might depend on the specific information on how often you want it to be updated. Other things is we have like extra space in our shared array for other things. So we only really keep track of like enemies and like flag locations. Other things you can consider you want to keep track of are like map symmetry. That's something like a big one. One idea we can throw out is like if there's a path with like a lot of walls and like your robot does like a path that's like kind of out of the way and like not immediately obvious, you can try communicating like certain paths around obstacles to enemies, to like ally robots. That one also seems a bit complicated, but it does seem like it would actually help your robots if they knew like directly what path to take instead of having to like bug nav around walls each and every time. I think those are like the main things I want to talk about. If you guys have any ideas of like things you want to put in your shared array and you want to be like I don't know if this is feasible to put in my array. I don't know if this is gonna be useful. You can like feel free to just like either send a message in Discord or like come up and talk to us. But other than that, I think that's it for this lecture. Unless anyone has any final questions. I don't believe so. You can feel free to just come up and talk to us and like we can show a demonstration at the end of the lecture if you guys want. But otherwise, I believe we are good to go. Okay. Thank you guys for coming, and then we will be back to lecturing again tomorrow about strategy. Tomorrow's gonna be a very fun lecture. It's gonna have a lot of cool demonstrations, so I definitely recommend you guys come tomorrow. Thank you guys.